So taking a look at rational functions continued, what if you have problems like this to graph? It's not as easy when it was just 1 over x plus 1, and that plus 1 means that it slides left 1. Or it was negative 1 over x, which just changes the quadrant. Or like 1 over x minus 3, which moves right 3. Or maybe it was 1 over x plus 2, and that moves up 2. Now we have these way more complicated rational functions. So you have to start by thinking, what are our points of discontinuity? It just means like, where do you have a break in the graph? Where are your asymptotes now? So where are we going to draw those x and y axes if we don't know where it's sliding around? Where is it going to be going up in a certain spot, down in a certain spot? Now that we're changing up these rational functions, things get a little bit more complicated. Okay, so the big thing with rational functions is finding out where are your asymptotes at, because it might not just be like the x and y axis. We might slide it around, or maybe it has 3 asymptotes. Maybe it's 2 vertical and 1 horizontal. And the best way to find vertical asymptotes is remember that your denominator cannot be 0. So if you have x plus 1 over 0, you can't have that. 2 over 0, can't have that. 5 over 0, can't have that. You can't have 0 in the denominator. So the best way to find those vertical asymptotes is to look at your denominator and go from there. So if x minus 2 equals 0, that's 0 times anything. That would give me 0. So x equals 2. Or x minus 3, if that were 0, that wouldn't work out. That would give me an asymptote. So x equals 3. And that's how you find your vertical asymptotes. You set your denominator equal to 0 and solve. So that's it. So you set your denominator equal to 0 and solve. Now remember, that means on your graph where it says x equals 2, x equals 3, that means at 2, that's where you're going to have one of your asymptotes. And that means at 3, that's where you're going to have one of your asymptotes. So my graph could go in here. It could go over here, it could go over here, but it can't be at 2 or at 3. And that's how you find your vertical asymptotes. So taking a look at this one, there's my denominator. If x minus 4 equals 0, add 4, one of your asymptotes would be at positive 4. Over here, if I have x plus 3 equals 0, subtract 3, x equals negative 3. And those are your vertical asymptotes. So on a graph, just sketching it out, I have one at 4, and I'd have one at negative 3. Now, we kind of did this before. If you had like 1 over x minus 3, and that meant that it slid right 3 to where x was 3, you set the denominator equal to 0, but there was only one thing, so it was a lot easier because it was just sliding around. Over here, when there's more than one thing, we got some more work to do. So taking a look at this one, look at my denominator. Based on that, one of my asymptotes is x equals 1. Over here, subtract 3, x could equal negative 3, and those are your vertical asymptotes. So vertical asymptotes, set your denominator equal to 0 and solve. Horizontal asymptotes are a little bit different because if I look at these, plus 1, if I had that, that means my graph would go up 1 and there's my horizontal asymptote. But as you can look at these fractions, it's not like you're adding or subtracting anything on the outside, so it gets a little bit more complicated. So horizontal asymptotes, on your pink piece of paper, it has this whole thing if you have like x to the power of m over x to the power of n. Horizontal asymptotes comes down to where is your fraction heavy? Is it top heavy? Is it bottom heavy? And that's how you do horizontal asymptotes. You'll see what I mean in a second. So horizontal asymptotes, heavy. Okay, if your fraction is top heavy, and this would be something that I would maybe write down on your pink piece of paper because it has a reference, it has it on there. If it's top heavy, an example of top heavy would be like x cubed over x squared. If it's top heavy, it's not going to have a horizontal asymptote. For example, y equals x plus 1 over 1. That doesn't even become that's not even a rational function. That's just y equals x plus 1. So if it's top heavy, like x cubed over x squared, it's going to have no horizontal asymptote. It might still have a vertical asymptote, but if it's top heavy, no horizontal asymptote. Okay, if it's bottom heavy, your horizontal asymptote is y equals 0. It just stays at that axis. So bottom heavy would be like x over x to the 5th power. Higher exponent on the bottom. The degree is bigger on the bottom versus top heavy, where it's something like this. Y equals 0. And if it's balanced, balanced would be, so if they're equal, balanced would be like x cubed over x cubed. Or x squared over x squared. Balanced, it's just your leading coefficients. Here's what I mean by that. If I have x cubed over x cubed and I have a 1 over a 1, then my horizontal asymptote would be y equals 1. But if it were 2x to the 4th over 3x to the 4th, still balanced because of those 4's, my horizontal asymptote would be y equals 2 over 3. So it's that. Okay, so how do you remember like top heavy none, bottom heavy 0, balanced leading coefficients? There is this crazy phrase to help you remember it. I'm going to write it down and then talk about what it means. And the crazy phrase is Bobo, yep, you heard me, Bond eats DC. So Bobo Bond eats DC. And I'm going to write this out and erase it, so just be careful. Bobo, B-O-B, means it's bigger on the bottom, so bottom heavy. So bigger on bottom, or bottom heavy, equals 0. So y equals 0. So bigger on the bottom, bottom heavy, y equals 0. Once again, I would write this on your pink piece of paper where you have room to write this. Also, because as we get into more and more graphing, that pink piece of paper just has all those rules on there for you. So that's Bobo, bigger on the bottom, bottom heavy, y equals 0. Okay, B-O-T, Botten. Bot stands for bigger on top. So Botten, bigger on top, or top heavy. N stands for none, or NA. So Bobo, Botten. Okay, eats DC stands for if your exponents are the same, you divide your coefficients. Like that 2/3, or 1 over 1, 2 over 3, could be 4 over 5, could be 5 over 5. So Bobo Bond eats DC. If you want to remember this and you remember Bobo Bond eats DC, like I just remember bigger on bottom 0, Botten bigger on top none, eats DC. I just remember balanced. For me, it's easy to remember like balanced LC, balanced leading coefficients. However you remember it, as long as you remember vertical asymptotes, set the denominator equal to 0 and solve. Horizontal asymptotes is the heavy thing. Where is it bigger, on the bottom or on the top? Think horizontal heavy. So pause it if you need to pause it and copy this down on your pink paper is where I would. And now we're going to actually look at some examples with it. So horizontal, I need to find out, is it bigger on the bottom, bigger on the top, bottom heavy, top heavy, or is it balanced? And that tells me my horizontal asymptote. So taking a look at this first one, x and x. That means that it's balanced because my exponents, my degrees are the same on the bottom, on the top. So balanced means divide your leading coefficients. So that's a 1. Oh. So my horizontal asymptote is 2 over 1, which is just 2. So y equals 2. That's it. Okay, looking at this one. Now I have x squared over x. So this is top heavy. Bobo Botten, bigger on top. There is no horizontal asymptote, so NA. If you get used to looking at this chart, that's fine, or however you remember it. Just remember you won't have that. You just have to have it memorized, which is where that Bobo Botten eats DC comes into place. Okay, This one I have x over x squared. So this is bottom heavy or bigger on the bottom, Bobo. So y equals 0. And then negative 2x plus 6 over x minus 5. X and x, they're the same, so negative 2 over 1, balanced. So divide my coefficients. What's negative 2 over 1? Negative 2. So y equals negative 2. So when starting by graphing rational functions, it's a lot easier to start with where are you not allowed to have points? What are you not allowed to have on your graph? Where are your asymptotes? That way you don't waste time plugging in points or picking out the wrong thing. And we're going to pick back up with actually graphing and finding out all of those values here in just a second.